Okay, today let's look at silicon rubber molds and why do I need to make silicon rubber molds. In most of the cannons that I make, a lot of the parts are castings, and I use lost wax casting, vacuum lost wax castings to make quite accurate parts. So I'll start off with drawing the parts on a CAD program. I normally use SolidWorks, although Fusion 360 is pretty good. From that I'll 3D print the part, and then I'll need to make a silicon rubber mold. Silicon rubber mold will then give me the injection wax, and from the wax I'll make a bronze or silver or gold or whatever material casting that I need. Okay, the sprue that you put onto your part's important because what it does is it allows for metal to be fed into the part as it cools. So this part must be bigger than the part you're casting. So if, for example, I used a smaller sprue, here's a whole pile of sprues that I've got. If I used that little one, what would happen then is your metal would feed through here and go into your casting. Then the smallest section would cool first and freeze. So this section would cool and freeze. So metal wouldn't be able to flow from your runner into your casting, and that would effectively be blocked off. Then your casting would shrink. As metal cools, it shrinks, and defects would form because of shrinkage cavities within your casting. Some of them would be visible on the surface, some might not be, until you try and clean it, and then you'd realize that you should have used a decent sized sprue in the first place. Okay, the silicon that I'm using is a clear silicon. You can get opaque silicons that you can't see through, white silicon or whatever color pigment you want to put in it. But I found that a clear silicon is good because once you've made the mold, your biggest problem is to get the air out of the mold and let the wax in. And to do that efficiently, you need to be able to see where you need to cut vents. On this mold, the silicon is a hardness of 45, shore hardness, which is quite hard. It's quite a dense rubber. Also, little thing to bear in mind is don't cut the cost of silicon. My wax pressure for injection is probably half a bar, which is about 14 pounds per square inch if I'm not mistaken. So this part's roughly 3 inches in surface area. So if I inject this part at half a bar pressure, I'm going to have about 30 pounds per square inch, or 30 pounds in total force trying to open this mold. So I need to push down on it with more than 30 pounds of pressure to stop the mold from opening and the wax from coming out. And if I've cut the costs and made this area here too thin, then I'm going to be squashing my mold and distort the part. So I need to make sure that the mold is wide enough and there's enough silicon to actually withstand all the forces of injection. The silicon rubber molds that I use, because my parts vary in size from tiny 1 millimeter diameter parts to bigger parts, I use different perspex boxes to create my molds. The silicon itself is a 2-part liquid that you mix together, vacuum it to take all the bubbles out, and pour it into the mold. So here I've got a part that I've put into the mold. I've got a little sprue at the bottom here. That's my ingate where the wax will be injected in, and that's normally bigger in section than any of the sections in your casting because you need to allow for shrinkage. I just use a bit of press stick in the back here to keep it in place and some super glue on the bottom and glue it fast, and then put the other half of the mold on and put super glue there and there, just a little drip on each corner just to secure it and keep it in place. Once that's done and it's set, then I use normal plasticine or modeling clay, roll it into a thin strip, and I put it around the edges to stop any silicon from leaking out. I find this to be the most effective way. Just close it up and then mix my silicon, pour it into whatever level I require. Okay, let's have a look at filling these 2 molds with silicon. Parts that we looked at earlier. I've put them in the box. I've sealed the box with plasticine, and now to calculate the volume of silicon that I need to fill this, there's 2 ways of doing it. You can either measure the volume of silicon that you require, or what I normally do is just take 2 molds that are similar in size and dump them on the scale and work out the volume of silicon that you need to mix. Here I've got 246, so let's make it 250 grams of silicon. Okay, silicon, as I said before, comes in 2 parts, part A, part B. Important to remember is that you don't cross-pollinate the two, because a little bit of catalyst in the base will harden the whole lot. So I'm going to pour in 125 grams of the base. Doesn't matter which order you do it. And then top it up with 125 grams of, well, that's 130. That's good enough. Okay, there we go. Okay, there I've got my silicon in the mold, in the bowl, and just mix it up. It's important to make sure that it's thoroughly mixed. The stuff's pretty viscous, so it'll stick to the bottom of the bowl, stick to the back of the teaspoon or the spoon that you're using. You'll see that I'm not really cautious about mixing air into it. The reason being that I'll put it into a vacuum chamber and I'll vacuum all these bubbles out. I'll show you the vacuum chamber and how it's mixed, and you'll see the silicon bubbles rising up, forms quite a frothy substance, and eventually the bubbles will break the surface tension and the whole foamy mixture will collapse back, and all the bubbles will be removed by the vacuum. So let's take it to the vacuum chamber. Okay, here we are at the vacuum chamber. Place it under there, make sure all the taps are closed. Watch the vacuum go up. Now you see the silicon starting to rise. Bubbles are starting to break, but I don't want it to overflow, so I'll just shake it gently. And now it's starting to collapse. There it collapses. Now all the bubbles are broken, and I release the vacuum. There we go. The bubbles that you still see there are probably caused by chemicals in the silicon, and they will just disappear. Okay, biggest problem that I'm going to have here is bubbles of air that get entrapped while we're pouring the silicon into the mold. This part's got a flat bottom area and be quite easy for air to get trapped under it. So what I'll do is I'll pour it in at an angle. So I'll just put a block of silicon under there for now. And as the silicon flows on the one side, it should push the air bubbles out.
There's still are quite a lot of bubbles in there.
Yeah, there's still a lot of bubbles, but like I say, most of those will either rise out or they will disappear, because it's not really air bubbles as far as I understand. Okay, let's leave that one. Let's do the next one. Okay, that should be enough. As you can see in there, most of the bubbles are starting to disappear already. Okay, the next step would be to remove any trapped bubbles. This little tool I developed, stick it in and remove any bubbles that you can see that are adhering to the surface of the pattern.
See if we can get in close there. Okay, so if there's any sort of circular pieces,
Yeah, any little air bubbles stuck in the corners of the parts, you can use it, or in small holes, you can use this just to remove the air bubbles, just to get them loose. Once they're loose, they float out. This will take about 15 minutes before it starts to set, and then if the air bubbles aren't out by then, they're not coming out.
so what you busy with today?
I've just taken these two molds out of their box and they look pretty good. I need to get the sprues out, which is easy as that. Good to take the sprues out first, because when you're cutting it out, the metal will damage the scalpel blade that you need nice and sharp. So here we can see the one part still inside the silicone. No problem to see that at all. That's why I use clear silicone, because now I can see it and I can easily cut it out. If I was using unclear, then I wouldn't know what's inside, and I'd have to start at the sprue and work my way around trying to remember what's inside. So I don't use that anymore. Another thing to look at when you cut the part out is I don't cut my molds in half, because if I've got a whole lot of molds in a box, sometimes 200 molds in a box, if they're in two pieces, it makes it 400 parts that you have to sort and put back together in order to get your waxes. So I cut them nearly in half. Another thing that I do is when I cut the mold, I make sure that it goes back together, can only go back together that way. So it's been cut very roughly with a flowing pattern all the way around, so that if the mold was in half, for example, it can only go back together that way, and it aligns itself perfectly. So let's have a look at cutting this one. The way I'm going to cut it, the parting line would be on the flat side, because it's a flat part, easy to cut it around. I wouldn't cut it down this way, although you could, but it wouldn't really make sense. So let's have a look. I start at the sprue, put the scalpel blade in up against the part, and then I wiggle the blade from side to side, and do the same on the other side. That ensures that when these two pieces go back together, it's like a jigsaw puzzle. It's not a smooth cut. It can only go back together in that way. Okay, when going down the side, do the same thing. Difficult to see, but I wiggle the blade from side to side.
Have you ever cut yourself doing this?
Oh yes. A small mold like this is actually quite easy to do. If you're doing bigger ones like this big block, it's really an effort, because the mold is very dense. There you can see the pattern forming. That's going to lock the two halves together. Flip from side to side, just so that I can try and get this 3D printed pattern piece out without breaking it, because it's quite brittle. If I did one side, then there'd be a lot of force put onto the pattern, and it's most likely it'll break. There we go, and there we have the piece out, and the mold is cut.
Okay, excellent.
I'm going to prepare this mold so that we can inject some wax into it and make a wax part of the part that we made the mold for earlier. So first thing to consider is the wax will get injected in there from our little wax machine. As the wax flows into the mold, the air's got to get out. So the easiest way to do it on a part like this, it's pretty simple because the part's very flat, is to put talcum powder between the two halves, and as you inject the wax, the talcum powder will allow the air to escape. But often you have a mold like this one. This is a section of a rack for the Dahlgren gun that I'm busy making. Each little gear tooth, as the wax will flow in, and it will go into the gear tooth, but it will trap the air in the edge of the tooth. So that needs to be vented. So what we do there is, once again, thank goodness for the clear silicone, but I hold it up to the light and then I will cut it with the scalpel, put it right through until I feel that it's gone through into the cavity of the part. Once that's done, there you can see I've got a whole lot of cuts. Then I'll put talcum powder into each one of those little cuts and make sure that it goes right through. If not, the silicone sticks to itself and makes a pretty good air seal and won't allow the air to come out. And then the wax will not fill the cavity like it should. So in this little part, there's only really one area, or make it two. This side here, the air will get trapped in there and won't give you a nice sharp corner, and that side there. The top's pretty flat, so I won't have any problems there. So what I'll do is I'll just hold it up to the light. I can see there's the edge that I'm looking for, and difficult to see because the silicone's quite thick. Put it through and hopefully we got it. And make sure you don't cut your finger in the process. And there we got it. I could also vent it by simply cutting a line from each corner like that. That's effective, but I like to use these little cuts because the mold is less likely to distort. Okay, next thing I must do is put talcum powder onto the mold. So here's my talcum. I'll open up that cut that I made, put the talcum powder right through from both sides. You can also push a piece of wire through just to make sure that the powder's gone right through. I'll use a little drill in this case because the talcum powder sticks in the flutes of the drill, and then it goes through quite simply and takes powder with it through to the other side. So there we have a powdered mold. Get rid of the excess powder, close it, and I use 2 bits of board to put equal pressure onto the mold. You'll be able to see the wax as it flows into the part. There it goes. I'll hold it for a few seconds, allow the wax to cool at that pressure, release the pressure, and there we have a part.
How long does it take to dry, or sort of allow you to open it?
That depends on the type of part it is and how thick it is. This part here, which is got quite a volume, that will take 5 minutes to cool properly, whereas this one's quite thin and the wax is it's sitting at 70 degrees Celsius, so it's already frozen, but it will still be warm. Let's open it and see.
Let's compare it to the original part.
At the moment, you can see the wax is still, here it's dark green. That means it's still molten. This is the color that it should be. This is frozen. So if I take it out now, I'll probably break off the sprue.
No, we'll just take the one that... No, don't take it out. There we go.
So if you enjoyed the video on how to make a silicone rubber mold for injection wax, then please don't forget to like us, and you can follow us on Facebook or Instagram, or if you want to see more on our products, especially maybe the silver cannon that I make, you can go to our website at www.palmersarmoury.co.za. Thank you.